Let us discuss this example. So in this example, we have a function from R3 to R, which is defined as 4x plus 3y plus 5z. Okay. So we have to find its total derivative. So you know the procedure, since in previous few videos we have already done that task. Let me write the given function first. We have, the function is f of x, y, z, which is equal to 4x plus 3y plus 5z. Okay, after that we need to take 2 points A and H. So let us take, let A is equal to A1, A2, A3 and H is equal to H1, H2, H3. So you know that we need to find f of A plus H and f of A. Let us calculate. Consider f of A plus H. Let us find its value. F of A is A1, A2, A3 plus H is H1, H2, H3. So you know how to add component wise, obviously. A1 plus H1, A2 plus H2, A3 plus H3, which is equal to, after that we have to use this definition to find its value. Definition says 4 into first component plus 3 into second component plus 5 into last component. So here also we need to do the same thing. So 4 into first component plus 3 into second component plus 5 into, right now, 5 into third component. So in this way we have calculated that f of A plus H. Let us find f of A now. Now f of A, which is equal to f of A1, A2, A3. Let us follow the same definition to find its value. So yeah, it will be, you can tell me, 4A1 plus 3A2 plus 5A3. So tell me, what is our next step? Our next step is to find the difference between them. Now f of A plus H minus f of A. Let us find the difference. F of A plus H already we have written here. See, but we can simplify it further. That means we can multiply each term of a bracket by that constant. So that's why what can I write here? 4A1 plus 4H1. Here 3A2 plus 3H2, 3A2 plus 3H2 and 5A3 plus 5H3 minus f of A. This is our f of A. But we need to subtract. So if minus sign is outside, all sign will get changed. So therefore we will have 4A1 minus 3A2 minus 5A3. So definitely we can cancel few terms. First is 4A1 minus 4A1, 3A2 minus 3A2, 5A3 minus 5A3. So the remaining terms are 4H1 plus 3H2 plus 5H3. See, after that our main task is to define a linear transformation, which is ultimately a total derivative. So let us define a linear transformation. We define a linear transformation. We define a linear transformation T from R3 to R as T of H1, H2, H3. See, by observing these terms, we need to define our linear transformation. Getting? So there should not be any square, cube or any higher power. But fortunately, we have got all linear terms. There is no square, cube. So I will consider the entire function. That means what we have, this is 4H1 plus 3H2 plus 5H3. So this is a required definition of linear transformation. Let us find the value of that term. So now our famous term, that is f of A plus H minus f of A minus T of H. F of A plus H minus f of A we have already calculated. So it is 4H1 plus 3H2 plus 5H3 minus T of H. And we have taken same term as a T of H. So this is 4H1 minus sign outside. So sign will get changed. Okay. So obviously all terms will get cancelled to each other. 4h1 will get cancelled with minus 4h1, 3h2 will get cancelled with minus 3h2, and 5h3 will get cancelled with minus 5h3. So obviously it is 0. Okay, so after that, yeah, that means we are on the right track. But see, we have defined h, but using epsilon delta definition, we have to prove that yes, this is the required total derivative. There is no more space, so I suggest you to make a screenshot of it, then we will go further. Okay, so to prove using epsilon delta definition, we need to take one epsilon first. Let epsilon greater than 0 be given. For this epsilon, we are supposed to find delta, which will work and satisfy the definition. But see, no need to worry because the value of this term is 0. So that means for any value of delta, it will work. Let delta be any positive real number. Okay, see, I will write full form number. Then norm h less than delta implies mod f of a plus h minus f of a minus t of h divided by norm h. See, but what is value of numerator? We have proved its value is 0. So that's why 0 upon norm h. 0 upon anything we will have 0, and 0 is less than epsilon. I will write some big 0. Huh? Yes. So 0 is less than epsilon. So therefore definition is satisfied. Let me remove this part. It is not required now. So therefore what we conclude? Therefore norm h less than delta implies mod f of a plus h minus f of a minus t of h divided by norm h less than epsilon. Okay, or the same definition we can write in terms of limit also. That is limit h tends to 0 mod f of a plus h minus f of a minus t of h divided by norm h is equal to 0. So therefore we can declare f is differentiable at a. Therefore f is differentiable at a, which is a1, a2, a3, right, belongs to R3, and total derivative is, we write in this way, df of a of h, which is nothing but t of h. And what was our definition of t of h? It was 4h1 plus 3h2 plus 5h3. But see, here a is any arbitrary point of R3, so therefore function is differentiable everywhere in R3. Therefore we can declare f is a differentiable scalar field. But a belongs to R3 is any arbitrary point, getting arbitrary point. So therefore f is differentiable at each point of R3. So therefore what can we declare? Therefore f is differentiable scalar field. Okay, so in this way we have completed this example. You can make a screenshot of it. After that we will stop. Thank you. Bye bye.